All right, so limits of trig functions. So we can still take this to infinity because lots of trig functions have asymptotes, right? You got your cosecants, you've got your secants, you've got your tangents and your cotangents. All of those have asymptotes. Yeah, so you can do the same kind of thing here with this. So I want to take the limit as theta approaches 0 from the right of cotangent of theta. Now, ladies and gentlemen, I am here to tell you, if you know what the graph of cotangent looks like, that basic understanding, use that knowledge. Use that knowledge. If you know that you have cotangent here, and I'm looking at, let me get something bigger here. I'm going to put this out right here. This is pi. This is negative pi. And cotangent is going to come down like this, right? As long as you know where those asymptotes are. If I'm looking at 0 and you know what cotangent is, then as I approach 0 from the right, what's happening? Where's my graph going? Positive infinity. Here, if I'm looking at this and I have the limit as theta approaches 0 from the left of cotangent, I'm coming down through here. Yes, and I'm getting it at negative infinity. If you know what the graph looks like, go with it. Done. Right? If you're like, crud, I can't remember what that cotangent is, but I know my reciprocal identities. Okay. I'm going to squeeze this up here. Here's another way to look at this. If I want to take the limit as theta approaches 0 from the left of cotangent of theta, but I know that this is the same thing as theta approaching 0 from the left of sine over cosine. Yeah, then you can be looking at this again, right? Oh, sorry, I said sine over cosine. Oh, I hope you're yelling at me. Wait, it's cosine over sine because it's cotangent. You're right. That's on me. Sorry. Yes. And this putting a 0 in the denominator because we know the sign of 0 is 0. 1 over 0, so I know it has to go to infinity of some kind. My question for you is, which one? Which one of that is going to be happening here? Look at how this is playing out. We know that this is going to be a 1 on the top. It's always going to be that positive value. But in terms of sign, as I approach 0 from the left or the right, here I'm coming from, oh, doggone it. Here I'm coming from the left. If I approach from the left, what is happening? Yeah, I'm coming from the negative side, right? If I'm approaching from the left, yeah, I'm approaching from the left. If I'm approaching from the left, I thought I had a positive there and I was looking at it saying, what is going on? No, I'm approaching from the left. I'm coming from the negative. So I've got a number over negative, and that is negative infinity because I put these backwards. Because I'm like, wait, part A to part B? My bad. Yes, I am approaching from the left. And then as I approach from the left, you come up with negative infinity, same thing. I just confused myself. That's not such a good thing, isn't it? What if I have the limit as theta approaches 0 from the right of cosine over sine? Again, I know this is 1, but if I'm approaching from the right, I'm up here at the positive. I'm up above that x-axis. So then I have that positive infinity. And I have this plus sign right here. So I have this with this, right? Good. So whether you choose to use sine and cosine, or whether you just go looking at the graph of cotangent, or whatever trig function it is you're looking at, that's up to you. All right? So however you want to look at it, that's up to you. But legit, if you look at those basic trig functions, right at the graph, you've got your answer. Good. Going to infinity. Doesn't matter if you're solving it from the graph, solving analytically, solving your trig, you all come up with it the same way. All right?